Okay, in this video I'm going to explain a little bit more about electrolysis, and we're going to talk about electrolysis in terms of the electrolysis of ionic compounds in solution. In the previous video we have spoken about the electrolysis of ionic compounds that are molten, but in the solution adds a little extra bit of information that we need to deal with. Just as a reminder, let's have a look at some of our keywords. So here we've got electrolysis. Electrolysis means, the lysis means that we are breaking or loosening, so we're just going to break something down. And we're going to break it down using an electrical supply, which is going to be a direct current, DC electrical supply. So we're going to break things down using electricity. As an example, here is sodium chloride. And if we break this down into simpler substances, then we form sodium ions and chloride ions that have been broken down from the sodium chloride. The other key word that we'll be talking about is electrolyte. And again, electrolyte means breaking or loosening, and this is going to give us these electrical charges. So in our example here, we have an ionic lattice, and if you remember, ionic lattice is held together so the ions cannot move by these electrostatic attractions between the oppositely charged ions. So this means it cannot conduct electricity. What we have to do is overcome these forces of attraction to break the lattice, and therefore the ions can move. We've got two options to do that. Number one is we heat it up, as we said in our previous video, and that makes it molten, and therefore these ions are free to move and it will conduct. Or number two, which is what we're going to talk about today, is we can dissolve the ionic compound in water. That also breaks the lattice, breaks the electrostatic attractions, and the ions are free to move. So what we're going to do is we're going to have a look now at an example, and we're going to look at the example of sodium chloride. So we have got sodium chloride, NaCl, and this is going to be aqueous. Okay, so we've got aqueous sodium chloride. Aqueous, remember, means in solution. That means, think back to what we just described, that means the ions are free to move because the lattice has been broken. And if it's in solution, that means it's in the presence of water, H2O. Now if you remember, water looks like this, and what water is able to do in this way is water is able to ionize, and if we do a little split here, that gives us a H plus ion and a OH minus ion. So water gives us a hydrogen ion, H plus, and it gives us a hydroxide ion, OH minus. So if we come back to our sodium chloride, when we put this into the solution and the lattice breaks down, that means this is going to form Na plus and Cl minus ions. Remember, if you're thinking, how do we know it's Na plus and Cl minus? Well, Na, sodium, is in group 1, therefore it forms an ion with a +1 charge. Chlorine is in group 7. If you remember the rules about valency, if you're in group 7, you form a -1 charge. Okay, so it separates into these. So what this means is in my solution, I have actually got sodium ions, hydrogen ions, chloride ions, and hydroxide ions. So in this example, when we're talking about a solution, we've got 4 ions to think about and consider. So let's have a look exactly what goes on. So let me draw a little bit of a picture. So this is going to be, here we have my electrodes, and then across the top we need a DC supply, and I'm going to make this side my positive and this side my negative. Let's put a little top on there as well. Okay, so there is my 2 electrodes, positive electrode, negative electrode, and inside here, if you remember, we have got Na plus, we have got H plus from the water, we've got the chloride ion, and we have got a hydroxide ion, all now loose, all now moving about inside here. Remember, this is a DC, direct current supply, and once this starts to work, we are going to end up with the positive ions are going to migrate So these positive ions are going to migrate towards the negative electrode. So these two go that way, okay? Why did it do that? Because opposites attract. These here, because they are positive ions, are called cations, and these cations therefore migrate towards the cathode. So the cations migrate towards the cathode. Okay, let's focus on those for a second. We'll do this in two stages. We'll look at the negative ions or the anions in a second. So they've migrated towards the cathode. Let's have a quick look over here at what exactly is going on. So at the cathode, the sodium and the hydrogen ions arrive. I'm just going to drag in another piece of paper here for a second. What we've got to consider now is the cations. These can go in an order of reactivity. Now I've only included a few here for reference. So we've got sodium is the most reactive in my list. Hydrogen would be here in the middle, and copper would be the least reactive in my list. So when they get to their electrode, what happens is the least reactive in this list is the one that is going to react or be reduced first. So for example, in our example today, these two here are arriving there. Sodium is the most reactive, therefore the hydrogen is the one to react or be reduced first. If I'm going to do another example in a separate video, the hydrogen ions and the copper ions would be present in solution, then it would be the copper ions that would react first because they are the least reactive. So using that as our example, that means we have to deal with the hydrogen ions first in our reaction because the hydrogen ions are less reactive than the sodium ions. So the hydrogen ions get towards the cathode, and at the cathode what we've got to do here now is turn this hydrogen ion into a hydrogen atom, an atom of hydrogen. So to do that, it's going to pick up a negative electron, and that will form a hydrogen atom. Now if you remember, hydrogen is diatomic, therefore it has to be H2. If that's going to be H2, we need two hydrogen ions to make that work, and therefore we need to be adding 2 electrons to the hydrogen ions to make that work. This reaction, because this reaction is, we are adding electrons, so this is gaining these electrons. If you remember that gaining is reduction, and we'll just have a quick look at why that is the case on here. So the way we remember this rule is using the phrase oil rig, and oil rig stands for oxidation is loss of electrons, reduction is gaining electrons. So in our example here, you can see that the hydrogen ion has gained electrons, therefore this is an example of reduction as a reaction. Let's put that out of the way. Right, so that's what's happening at the anode. So have a quick little recap of some other bits and bobs linked to this. This is hydrogen. Question, how do we test to show this gas is hydrogen? Hopefully you remember that we've got the pop test, so that involves putting a lighted splint inside, and if the gas is hydrogen then it will pop. Right, let's jump back to the anode. So this side of the electrolysis process, this is where these anions, negative ions, are going to migrate this way. So these are the anions, and because they're migrating this way, this makes this positive electrode known as the anode now. So at the anode, okay, here is my anode, we need to consider what's going to happen here, because complication, we've got 2 ions, 2 anions arriving. Which one of these 2 is going to go first? We're going to bring in the second half of this little sheet to help us. So what we need to consider here now, here's a list of all the anions that we need to be aware of. So the top row are all my single charge, they're all my halide ions. Underneath that we've got a hydroxide ion, and underneath that we have got a sulfate ion, which is a 2- ion. Now if we were to count up the number of atoms in each of these ions, we can see that all of these halide ions contain 1 atom in the ion. Hydroxide contains 2, 1 oxygen, 1 hydrogen, and a sulfate contains 5, 1 sulfur, 4 oxygens. So that means we've got the number of atoms is 1, 2, 5 inside these ions. When we look at which one of these is going to react first, then basically the simplest is going to be the one that is going to oxidize or react first. This is the ease of oxidation. So if we had a halide ion with a hydroxide, the halide ion is going to go first. It's going to be the one to oxidize first. It's got the simplest formula, is a way to remember it. If we had hydroxide ions and sulfur ions in solution, then this one's got 2 atoms in the ion, so it's got 5. Therefore, this one is going to oxidize before the sulfate. So the hydroxide will go before the sulfate. That's a quick and simple way to help you to remember which anion is going to be the first one to react. So, using our example, these 2 anions head across. This one's got 2 atoms in, this one's got 1. Therefore, it's going to be the chloride that is going to react first. So I'm going to deal with the chloride. This is a negative ion, and what we need to do at the anode is it needs to become a chlorine atom. So to do that, it needs to lose this charge. This charge needs to be released. So there's the electron that's being released. We know that chlorine is diatomic, so it's Cl2, and because it's Cl2, we need 2 of those and 2 of those, and that is going to give us the correct equation. So we've got 2 chloride ions forming a molecule of chlorine Cl2, releasing 2 electrons in this case. Let's remind ourselves, this is being released, this is being lost. These electrons are now not part of the chlorine, so they've been lost. If we come back to our oil rig, oxidation is loss. So this example here is an example of oxidation. And this side compared to this side, remember this now is adding these electrons. So this one was reduction. So we're getting chlorine here. Little quiz to remind yourself. How do we test to show this gas is chlorine? And if you remember, you get yourself a little damp piece of litmus, red litmus, and this gas will bleach that litmus to white to show that the chlorine is present. A little question to think about. If all the hydrogen has reacted, so if all the hydrogen undergoes the reduction process, what's going to happen next inside the electrolysis process? The answer is that once all the hydrogen's gone, the sodium has to go next. So the sodium will then start to undergo reduction itself. And the same is true on this side. If once all the chlorine is gone, then the hydroxide ion will have to undergo oxidation itself. Now, to do this, you need to be able to explain this process in a couple of examples. You need to be able to explain this process for copper chloride in solution, so CuCl2. We've just done sodium chloride. You have got copper sulfate, CuSO4, again in solution. And another one is sodium sulfate, also in solution. So what a good little test to be would be to have a watch this video again, get yourself familiar with what's going on, and then try these 3 to see if you can work out what is going to be formed, which is going to be formed, remembering that they're all in solution, therefore they all produce, as it shows you at the top, hydrogen ions and hydroxide ions in addition to the ions contained in each of those formulas. Hope that's useful, hope that helps you to do this. The key to this kind of work is to really just practice this, have a go at it, get that repetition in there, and if you keep going over this and explain it to yourself, then you will definitely sink in. It is tough, it is challenging, but get those sleeves rolled up, get stuck in, and good luck.